Hi everyone, thank you for being here. I will present my work, Cognitive Canvas, Cognitive Enhancement through Text-to-Image Diffusion Models. So the problem we touch on is text-to-image models. They mostly optimize the prompt fidelity, like how to adapt for the given prompt. However, they don't have the concept of like what are human-relevant cognitive attributes like memorability, aesthetics, or preferability, and how to optimize images according to these attributes. Similarly for editing methods as well, like they know how to edit images for a given prompt, but they might not know what these attributes actually mean. So for to make an image more aesthetics, you might need to tweak your prompt and regenerate images. However, this is not a controllable approach. Why does this matter is that so you might want to make the images more memorable, let's say for campaign, for products, or let's say in education for learner engagement. So before this type of problem was studied in Generalize, which is using GAN models. So this has the limitation of using GAN models because it's only fixed to GAN categories. It is not generalizable to any other concept. And also, this can only work for GAN-generated images. So you might not give any random image and ask it to edit the image. It only works on like GAN-generated images. There are some methods that optimize prompts for a concept like aestheticity. However, they only work for generation. So you might generate an image, but there is no controlled way of making it more aesthetics or less aesthetics. And also, they mostly touch on only one concept, which is like aestheticity. However, in this work, we are trying to generalize it for any cognitive attribute. So we use reinforcement learning policy over a frozen diffusion editor, conditioned on concepts and applicable to any image for editing. So this is the framework overview. What we do is using a large language model as a policy, and it proposes an editing prompt. And after taking this editing prompt, we use an external image editor, which is like one image edit, and we check how much the classifier score changed using the input image and edited image. And observing this difference, we return this difference as a reward for the policy. And we also don't want the model to diverge a lot from the base model. So we also have a KL loss here. And let's say at each rollout, we get some editing prompts, we edit the images, and then getting the difference, return this as a reward to the model. And this way it optimizes and learns what type of edits can increase this concept classifier score or decrease. So we use a llama model as a base model and QN image edit as an image editing model, which is frozen, and we use black box evaluator. So this could be any concept classifier. So these are some qualitative examples. In the leftmost side, we have memorability. So we can see that like increasing brightness, we can actually increase memorability score. Or for aestheticity, for changing the color, making the mirror red, or adding some background objects might increase the aestheticity. And for human preference score, we use like HPS scorer, and zooming in or adding some background objects again can increase the human preference score. So for comparisons, we use some editing models, and which is like Q1 image edit, lattice plus plus, flux1 context. However, as I mentioned before, these editing models doesn't actually know what is memorability. So our editing prompt here is like make it more memorable. But as you might see, the image doesn't change a lot from the reference image. There is no observable change. But to make a fairer comparison, we also prompt GPT-4 and ask for editing prompt for a given concept. Let's say we ask for GPT for editing prompts that can increase the memorability. So as you can see, it actually achieves to increase the score but it's mostly not diverse. So here it mostly proposes like making putting some vivid colors. However, in our method, it's like changing the color, brightness, or increasing the contrast are some discovered concepts here. So these are some examples for aestheticity. So similarly, some base editing models cannot change the image a lot. For GPT-4, for mostly aestheticity, it again proposes changing the colors. However, for aestheticity, it mostly drops the scores. And our method is the rightmost one, which change the colors or brightness and so on. And these are the results for human preference score. In case of GPT-4, it actually increased the score mostly. However, in the last three rows, you might see that it mostly adds so far regardless of the context. So it is overfitted to one objective. Like it knows that SOFA can increase the score, so it mostly proposes that type of edits regardless of the concept. In our methodology, like in the first image, it proposes adding some plant, zooming into the subject, changing the background, or even changing the structure, like changing the cream in the last image. And we present quantitative results, observe the score changes, mean score changes for each classifier. And we also learn targeted edits for suppressing the content. So like for memorability, we try to decrease the memorability, let's say. And as you can see, our method has the most score change, and GPT-4 Q1 follows our methods. We also observe what are the emergent factors here, and we have some metrics for brightness, redness, colorfulness, entropy, normalized area, centeredness, squareness, to see how much these attributes are changed in each editing method. So you can see that GPT-1 has the most change, which means it changes the images mostly, and ladies, let's say, cannot change the image a lot. Ours is more in the middle. It changed the image, but not as much as GPT-1. And we in the lower bar, we showed the distribution of dominant edits. So we want to observe what type of edits, what are the distribution of these different edits. So in GPT-1, it's mostly change the color. The green bar is colorfulness. So it knows the colorfulness change the memorability. So it mostly proposes colorfulness. But you can see the other methods are more balanced. They change colorfulness, centeredness, entropy, and brightness. We also perform some experiments how the edit diversity is, and to observe the generalizability. For diversity, in addition to the other experiment, we also look at the Venn score. So GPT-4 and our method is the only one that proposes edits. So we compare these two methods, and our proposed edits Venn score are higher than GPT-4 Q1, which also shows that it has more diverse directions. And we, for generalizability to real images, we get some images from the Magic Brush dataset. So even that our model is optimized using synthetic images generated by Flex, it can still generalize to the real images. So you can see for memorability, there is like zoom in, color change, and brightness changes. Also, as a cross-classifier validation, so we use one classifier score to optimize our model, but we also expect it to be able to generalize to the other classifiers as well. So for this objective, we use a Lion aesthetic score and also Redman for memorability, and we can see that there are also some significant changes using these classifiers as well. To perform user study, we get like edited images from each method, and we randomize the order of these methods for each question, and we ask the user which one is like more aesthetic, and similarly for other concepts as well. And users can select only one option, like which is more aesthetic, and at the end we get the ratios of the preferability of each method. And in the bar plot, you could see that for memorability, aestheticity, and human preferability, our method is the most preferred one. GPT-4 follows that, and it's mostly that flag context, human, and ladies comes later. So some limitations are that these classifier might have some biases. For example, for aestheticity, we know that like models might learn that makeup might increase more aestheticity. So our optimization methods that are directly based on these classifier score changes, so they might also learn and carry these biases. And also, so in the right figure, you could see that for aestheticity, it proposed some irregular crops which increase the aesthetic score, but it might not be realistic or preferable. Or similarly, proposing some edit directions like over stylization for memorability. As a summary, we propose a reinforcement learn-based framework for cognitive editing using frozen diffusion editors. Our objective here is to learn diverse concept-aligned edit strategies. We outperform all the baselines that are editing models and also GPT for proposed edits. And we show that it can generalize to the zero-shot real-world images. And we also perform a user study and show that our method is the most preferable one. Thank you very much for listening.